My name's Cathy Murphy. I'm a professor of chemistry here at U of I. I was an undergraduate here myself, so I've loved chemistry for a very long time. And in my laboratory today, we work at the intersection of inorganic chemistry, materials chemistry, biophysical chemistry, and nanotechnology. The main program in my lab is to control the crystal growth of metals on very small length scales. So we know what gold looks like in the bulk. Gold looks golden. But when you shrink gold particles down to a very small size, you get a rainbow of colors. In fact, I have some here. This is commercially available on Amazon.com. These are colloidal gold particles that are about 20 nanometers, about 200 atoms across, and you see it looks kind of red. So people have known this for thousands of years, actually, that finely divided metals have different optical properties. And one thing we've been able to do is control the crystal growth of these particles on very small scales to get a rainbow of colors, so the shape of the particle controls the optical properties. When you shine light on these particles, you get a whole plethora of effects, and you can use these effects to do a lot of things, such as chemical sensing, biological imaging. You can generate local heat from these particles when you shine light, and that is interesting because you can do several things there. There's applications in photothermal destruction of tumors, so if you can send your particle into a tumor, shine light, you ablate the tumor. So there's lots of technical applications of these materials, but we're on the front end making them, characterizing them, doing their surface chemistry, interfacing them with different systems. So we developed a process in around 2000, 2001 called seed-mediated growth. So what we do is to control the crystal growth on very small length scales, it would be very lucky if you could just mix things and have it work, but that's not how it goes. So what we do is we make a seed crystal first, very small seed crystal, and then we take these seed crystals and put them in a fresh pot and add more metal, salt, and more chemical reagents, and then other materials in the pot, and then they will grow at room temperature in water and air to the desired size and shape, and then we stop it. So it takes a long time to figure out all the conditions for that, but we've gotten pretty good. I've got great colleagues in a diversity of areas, so if there's something I want to learn more about, I almost always can just walk down the hall and ask somebody something in more detail. We have a great group of students here. Illinois is a big program. It's been a big program in chemistry for decades, and so we get excellent students coming through, and we have fantastic facilities. Most of the experiments we do require imaging of our particles on very small scales, and you can't do that in a regular microscope. You have to go to an electron microscope, and luckily for us, the Materials Research Lab up the street here has acres of electron microscopes with excellent staff to maintain them and very good training of students on them. So we have amazing facilities. So it's very exciting to be at the forefront of something because you're at the frontier, you don't know what's going to happen, you hope you know what's going to happen, and then something else might happen, and then you can go on a new pathway and find new things. So we're learning all the time, and that's one really exciting aspect of the job.